Third technique that we're going to review is the elimination method to solve a system of linear equations. As the term says, elimination method, we want to eliminate one of the variables x or y in our equation. And we can do this by multiplying one or both equations by a number that results in equations that contain opposite terms. I'll kind of talk about that in a minute. And then we want to add those equations together so that one of the variables is eliminated, solve that remaining equation, and substitute that value back into your original, one of your two original equations. So that's this process I'm going to talk to you about as I work through this first example of 5x plus 2y equals 340 and 3x minus 4y equals 360. It's not a great candidate for substitution because none of the coefficients are 1, so we want to look at exploring a different method. Our goal is to either eliminate the x's or the y's by adding these two equations together. Well, if I add these two equations together right now, we can see that they don't eliminate. We'll have 8x minus 2y equals, and whatever that is, we did not eliminate a variable. So when we do this, what we want to have happen is when we add these, either the y's or the x's, we're going to eliminate them. When we add to eliminate them, they need to have opposite signs. So really what I want to be able to do is create something up here that's a positive 4. If I could take a positive 4 and add to a negative 4, they eliminate. So here's what we need to do. We need to make sure that we get the same numbers with the opposite signs either on the x's or on the y's. It seems easier to me to take this top equation and multiply it times 2. That would create a positive 4y there that would allow us to eliminate the y's. So that's going to be my strategy. I'm going to take this top equation, 5x plus 2y equals 340, and we're going to multiply the whole thing times 2. So I'm going to put the parentheses around to indicate that I multiply it by 2. And then I'm going to multiply it over here on this side, so 5 times 2 is 10, so we got 10x, and 2 times 2 is 4, so that's 4y, and 2 times 340 is 680. Now the bottom equation I'm not going to change or alter because it has the opposite sign of the positive 4y, so as long as I get them to have the same values with opposite signs, I'm good. So I'm looking for opposites, so 3x minus 4y equals 360. Now in this technique, the next thing we want to do is we want to take and add these two equations. What we're doing is we're adding equals onto equals and they stay equal, but when we do this, we'll have 13 x's. The y's, when we add them, eliminate because they'll end up being 0 equals, and then we end up taking 380 plus 360. And that ends up giving us 1,040. We can simplify this equation and solve it for x. So now I know that x is a result of 1,040 divided by 13, which is 80. So now I know the x coordinate of the ordered pair where these two lines intersect is 80. So I know that. Now we need to go and find the y value. Now what we can do now is, since we know the value of x, we can plug that in or substitute it in for y in one of these two equations. It can either be in the first equation or the second equation. So I'm just kind of looking at two equations thinking where it'd be easiest to plug it in. I kind of like working with the positive, so I'm going to choose that first equation. I'm going to replace the x with 80, and then plus 2y equals 340. So that gives us a 400 plus 2y equals 340. So that gives us a 2y that's equal to a negative 60. And that means that y has to equal a negative 30. So the y coordinate of the place where they intersect is a negative 30. This should be the value of the ordered pair, the x and the y combination, that satisfies or makes each of those two equations true. So there's an example of the elimination method.